last bit of summary that we're going to do before we do some practice questions is putting in all these reagents that we know for every reaction that we know. So this empty flowchart is on OLE, and you can go through and put in the reagents and then also classify the type of reaction with me during this video. So let us start with the alkenes because they've got the most reactions. So if I want to go from an alkene to an alkane, so we're going from here up to here, remember that we need to add some hydrogen because we need some hydrogens across those double bonds to get those hydrogens. We also need a platinum catalyst, and we need to heat that up. And don't forget that's an addition reaction because we're adding hydrogen across the double bond there. The same thing happens if we want to go from an alkyne to an alkene. Can add hydrogen with a platinum catalyst and heat. Cool. If we want to go to a dihaloalkane, so alkene to a haloalkane when we've added X across, and remember I've put a note up here, X could be Cl, Br, F or I, so any of those group 17 halogens. So you need to add X2, so like Br2, Cl2, and so on. And remember, that's a really fast reaction. That's that bromine one that's really quick with alkenes. Again, that is addition because we're adding across the double bond. Oh, just a quick note before we move on. I did mention this in a previous video, but this R here, all of these R's, just means like whatever else can carry on going on this chain. So if this could be just one more carbon, it could be like a lot more carbons. We just use R to say it's just carries on repeating, just keeps going. Okay, so alkene to a haloalkane, but just a mono haloalkane, so just like one halogen rather than two, like we saw up here. We want to add HX. This is also fast. So like HBr, HCl, HF, HI, any of those, so that we can get that hydrogen adding onto the other carbon instead of like two chlorines. So we can just get one this time. If I want to go to an alcohol, I need to heat this up. And I need some water, and I need it to be an acid. And we looked at doing this, some water with some H2SO4, so dilute sulfuric acid. You can also see this written as H2SO4 aqueous, like just like that, because aqueous obviously means it is dissolved in water. So as long as you're showing that the acid needs to be present and water, so it needs to be dissolved in water. And then we get the H adding across the double bond and the OH, the other part of the water. So that's hydration because we're adding water across the bond. So again, addition. To make a polymer, so remember we break this double bond of the alkene and then we just repeat them over and over and over again. We just need to heat it up with a platinum catalyst and obviously lots of the alkene, so we can just keep breaking those alkene bonds, giving us that extra bond on the end for them to just keep adding together. And remember, one single broken alkene, alkane now, is called a repeating unit. So it's got those bonds on the end to say that it just keeps going, because you'll typically have like hundreds or thousands of these in a chain. Again, addition. If you'd like to add the two hydroxyl groups to make a diol, so we look to making an alcohol, but a diol, so you can make this through oxidation. We use permanganate, must be an acid, and remember we needed to reflux this, so heating it up but keeping it sealed. So we reflux that to form the diol. That is oxidation. Okay, maybe let's come over here and look at an alcohol to an alkene. So instead of hydration, I want to do dehydration. So for here, I need to use concentrated sulfuric acid for that one there with a bit of heat. So you can sort of remember this as dilute sulfuric acid, and then to go back to the alkene, we've got to use concentrated as a dehydrating agent. Okay, looking at going from a haloalkane, let's look at these reactions, back to an alkene, we want to use KOH but alcoholic. Remember the opposite of that was using KOH that's aqueous, and then we go to the alcohol. So this would be elimination, this would be substitution. Let's just look at an alkane to a haloalkane. We also use X2 here, but remember it's really slow, so you'd have to use UV as well to speed that up. Looking at an alcohol to a haloalkane, we'll need to substitute the OH for our halogen. If the halogen is like bromine, fluorine, iodine, we'd have to use HX. But if it's chlorine, we've got a few options. We could use HCl, PCl3, PCl5, SOCl2. Any of those options. Looking at a haloalkane to an amine, so I want this to be an NH2 group, so another substitution. I need to use concentrated NH3 and some heat with that. If I'd like to take my alcohol, primary alcohol, that must be primary, to a carboxylic acid, so this is oxidation because I'm adding in an oxygen. I need to use an oxidant, like dichromate, must be acidified, or permanganate, must also be acidified. This also needs to be done under reflux, heating it up. Okay, then we can have a look here. These are all acid-base sort of reactions. So I could add a base in here, like NaOH or Na2, CO3, like a carbonate or a hydroxide. Any of those would be good. To go from an amine, this base, to the alkyl ammonium salt, like propyl ammonium, I've got chloride here as an example, you'd need an acid, like HCl, for example. That's where we get the chlorine from. And remember, we can add our carboxylic acid with our amine, and we can make the alkyl ammonium carboxylate salt. So quite a bit of a mouthful to get that down. But yeah, so for example, like propyl ammonium ethanoate would be the salt's name. So if you can go and do this on the slide as well. So remember, we've got, this is all of them put together. You should probably add UV in here though. And this is them color-coded for their types of reaction, because you need to know those too. So hopefully this helps to kind of get them all clear. There's so many flowcharts if you don't really like this one. On No Brain Too Small, there's loads there. There's also some on the GZ Science. All these links are on our OLE page in tiles. This one is color-coded though to match my slides. So all of the stuff to do with alkenes is got orange headings if you go back in the slides, just to kind of make it easy to follow. But yeah, loads of these, so just find one that really clicks in your brain. If you're not a flowchart kind of person, maybe flashcards. You will need to remember these though, so whatever works for you, just do it. Mind maps work for me, but yeah, you need to find what will work for you.